Oh, hey peeps. Next in our Math Bootcamp series is the process of evaluating an algebraic expression. You may have done this as far back as middle school, and who knows, maybe some in elementary school, possibly. You probably were given an acronym known as PEMDAS that represents the order of operations. And it starts with parentheses. So if you have an expression, you would want to evaluate the parentheses first, exponents second, then the operation of multiplication or division next, and lastly, you would evaluate anything that uses the operation of addition or subtraction. So what I'd like to do is try a few examples out to demonstrate this PEMDAS in action. Okay, example 1 actually showcases a legit physics equation that represents motion. We'll be studying this in several weeks. And it says that d, which is distance, equals v naught. Yes, this little o is pronounced not, kind of like naughty, but it's, I don't know, do it very British, I think it works, not, v naught. The o could also stand for original, so it's the original value, the initial value, plus v, standing just for velocity at some later point, times t, time. So there are some values that have been provided to evaluate the expression. We have v naught equal to 30 meters per second. Notice the units, we're going to stay in this MKS system, meters per second. V equals 50 meters per second, t equals 10 seconds. So I've written the equation up here with the values populated. So I've plugged in the values, and we're going to use PEMDAS to evaluate this. D equals 30 meters per second plus 50 meters per second in parentheses divided by 2 times 10 seconds. Okay, great. PEMDAS says we would evaluate the parentheses first. In the parentheses is the order of the operation known as addition. That's the only one we carry out. So let's do it. We have D equals 30 plus 50. So that's 80 meters per second. Okay, adding the same unit together gives you the same unit. And that would be divided by 2 times 10 seconds. All right, so we're almost there. Now we can choose to either divide or multiply. When you have those two operations, the order which you choose doesn't matter. There's some mathematical law that allows us to do it, and because I'm not really a math teacher, I don't know what it's called, but I can teach you how to do it, so that's just as good for our physics. Okay, 80 meters per second divided by 2, so that's 40 times 10 is 400. So our final answer is going to be 400, but 400 what? The units are important. We get 400 D, and the unit is meters. And actually, it works out from a perspective of units. We have meters per second here times seconds. The seconds would cancel out, one in the numerator, one in the denominator, and so we get just the meters. So that's terrific. That's our answer, 400 meters. Now, the next one's a little more complex. Example 2 is this equation over here, another legit physics equation of motion that we'll be getting to maybe about 3 weeks or so. So a little bit after this one, because it involves something called acceleration, which is the change in speed or velocity, or even direction. V naught equals v squared minus 2ad, and all that is the square root. Okay, so we have v equals 8 meters per second, a equals 2 meters per second squared, and d is 7 meters. So again, I've taken the liberty of establishing our plug-in of values, the population of the values into the variables. We have v naught equals the square root of 8. Now, this is 8 squared, I should say, because it's v squared. So good thing that I've got this handy marker here, so I can throw in the squared. Minus 8 squared times meter squared over second squared, because the units got to get squared too. Can't do just the number and get away with it. You got to do everything. You got to square the whole thing. So 8 meters per second, the whole thing is going to be squared. So 8 squared, meters squared, divided by second squared. Minus 2 times 2 meters per second squared from A times 7 meters. Whew, there's a lot there. All right, what do we do first? Well, there's like a couple things to do. We could do this exponent first. That would be cool, because everything really is contained within this square root. I'm going to rewrite the square root another way to make this a little more obvious here. V naught equals parentheses. I'm just going to square this out right now. 64 meters squared over seconds squared minus, well, 2 times 2 times 7. Okay, that's 4 times 7, 28. Also meters squared over seconds squared. That's important that we keep track. The meters here, meters times meters is meters squared divided by seconds squared. And then, the whole thing is actually raised to the 1/2 power, which is the square root. So in effect, what we have to do is evaluate everything under the radical, everything in the radical which represent the parentheses, do that, and then lastly, we'll take the square root and we'll all be quite happy. All right, so let's do that. Since the units are the same here, they match, meter squared over second squared, meter squared over second squared. We can subtract them. We can totally do that. When I first did this, I forgot to square stuff and everything was screwed up. That's how I knew I made a mistake. I did that check. And so this is like take 2 or 3 now of this video. Units work when you check them. 64 minus 28 gives us V naught is the square root of 36 meters squared over second squared, which is equal to 6 meters per second, the unit which we would expect for V naught over here, velocity. All right, and we can box that in. Notice that I had meters squared divided by second squared, but when you take the square root of a square, you just get the base. You get the root like that. All right, evaluating expressions, PEMDAS, and 2 examples. Right on. Thank you. Morad out.